Okay, well, welcome. We're going to try and show you the specific heat capacity compulsory practical for the Physics P1 paper. This comes up in the energy topic, and it is also something that you would have come across in class. So I'm going to talk you through it. What we're going to do, the specific heat capacity, it's not something used in everyday language, but it is something that's important, and it relates to the different materials that we have. And what we're going to try and do is work out how this relates to this particular material which I've got here in this practical, which is aluminium, but we can do it for any material, and we can do liquids as well. Specific capacity refers to the amount of energy required to heat 1 kilogram of material by 1 degree. And that's what this experiment is going to do. It's going to allow us to do those measurements. Now, the formula for specific capacity works like this, and it is one that's given to you in the exam. If you have a look in the front of your formula sheet, you'll see one that says that the energy required, or the amount of energy going into a system, is equal to the mass times the specific capacity, which has the letter C, times by the temperature difference. And what we want to do is work out C. Now, for that, we always try to rearrange the equation, and you'll often see people use the triangle. That works quite nicely. So what we're going to do, complete the triangle here with energy at the top, mass, specific capacity, and change in temperature. And as we said before, if you cover up the thing that you want, we can then work out how to calculate that value. Because we want to work out specific capacity, I'm going to cover up C, and we're left with energy on the top, and mass, and the change in temperature on the bottom. Okay, so what we need to do in our experiment then, we're trying to calculate specific capacity of a material. We need to know the energy that we're going to put in, the mass, and the temperature difference. So if we have a look at what we've got here, this is a standard piece of experiment. What we've got here is a 1 kilogram block of mass. If I wasn't sure what the mass was, I could always take that and weigh it with a mass balance, but it's cut here to 1 kilogram. I've got a heater, which is going to allow me to put energy in here, which is then going to hopefully warm up the block. And I've got a device to help me measure the amount of energy that's going in. Now here I've got the higher level one, which is to use a combination of an ammeter and a voltmeter. And if I do the ammeter, the current times the volts, times the time I've got it on for, that can help me calculate the energy. It's a straightforward equation I'll write down quickly so you can see. That is the total energy going in. This is for anyone who's on possibly the height here. It's going to be the volts times the amps times the time that I've recorded on my stopwatch. And obviously the longer I leave it on for, the hotter it's going to get. So just quickly then, another solution on the basic paper is to use a joule meter. Rather than having to use the power supply and the ammeters here, I could just use the joule meter, and that would tell me exactly how much energy is going in. So here's the system. I'm going to start it off. We haven't got time to finish the practical off completely, but what we're going to do is make sure my heater's inside the block. I've got a little bit of water in there to help improve the contact between the heater and the block itself, so the heat transfers more evenly. And I've got a thermometer, which you can see is placed a little bit away from the edge. So it's going to measure the heat as the heat travels through the block and starts to warm up. So I'm going to turn my power supply on. You can see immediately I've got a current, I've got a voltage, and I'm going to start my stopwatch. And I'm going to heat this for probably about 5 minutes. And in that time, what I'm expecting to happen, I'm not going to touch anything because this is going to start to get warm. And in that time, as it starts to heat, the energy is going to be transferred to the aluminium block. Now you'll notice on a safety mat, what I could also have done was put some insulation around it, because as that block starts to warm up, it is going to start letting energy into the room. And that's going to be a slight problem. It's going to affect my results slightly, because what I really want to do is keep this insulated. But if you assume we've done our 10 minutes, and we haven't got time to do that now, but if I have the 10 minutes finished, I turn my power supply off. And what I'm hoping to do is be able to put the information that we've got from this chart into my formula. So if I'd had it on for a certain amount of time, I may have something along the lines of 1,000 joules of energy going in from my joule meter or from my calculation from the ammeter and voltmeter. I've measured the mass. In this case, it was 1 kilogram. And what I'm really interested in seeing is what the temperature rise. So if I measure the temperature at the start, and I record the temperature at the end, I can see how much the temperature's gone up by. For example, if this one has gone up by 20 degrees centigrade, I can place the numbers in my formula, put them in my calculator, and work out what the specific heat capacity is for that material. That is the specific heat capacity experiment. Thank you very much.